In this video, we're going to take a little look at what embedded systems are and how they differ from computers that we have traditionally discussed. Typical systems rely on something called Von-Neumann architecture, and it was first published in 1945 by Von-Neumann. Modern computer systems still rely on the principles that he put in place. Those were that to complete tasks within a computer system, you need to have some form of central processing unit, which contains a control unit which oversees operations and decodes instructions, an arithmetic logic unit, a part that can complete mathematical, logical and shift operations, and registers, which are some places where data can be stored. And we've previously looked at some special purpose registers which holds certain data. We also have a memory unit which is used for storing data and instructions alongside each other. In addition to these parts, we have input devices which feed data into a system and output devices which bring that data back out into the real world. Now, what we can't see at the moment is how we actually transfer data between the central processing unit and the memory unit, and that's done by something called buses, and they also carry data between the central processing unit and the peripheral devices. Now, first of all, we need to have a little look at something called the system bus, and that is made up of three individual buses. The address bus, which sends addresses from the central processing unit to the memory unit. In modern computers, we call this RAM. The data bus, which can carry data from the CPU to the memory unit and also send it back. And the control bus, which can send signals between the central processing unit and the memory unit. Let's take a little look at an example of how this would work in practice. Let's say that the CPU needs to load data from location 58. It would send location 58 along the address bus to the memory unit, and then in response, the memory unit would send the data from location 58, which in this case is 99, back along the data bus to the CPU. Store operations work slightly differently in the sense that we have to send the location we want to store some data in and the data itself, and they go along two buses. The location along the address bus and the data along the data bus. The memory unit can then handle storing the correct data in the correct location. Now, there are lots of different types of devices that use Von-Neumann architecture. Your smartphones, laptops, desktop PCs, all-in-one PCs, tablet devices and games consoles. These all have an operating system which manages the interaction between the user and the hardware. When we talk about operating systems, we're talking about things like Windows 10, iOS, macOS, Linux. You've even got them built into games consoles, and they have specific operating systems designed for those consoles. Embedded systems work in a slightly different way. They don't have Von-Neumann architecture as such. They generally have a dedicated function and work as part of a larger device. They can also work as individual devices on their own. And components are often manufactured onto a single chip or a little circuit board which has a microprocessor that carries out very basic functions or very limited functions. Any device that's got some form of interface will have an embedded system running behind it. And when we talk about an interface, it's a method through which a human can interact with that system. Now, if you look at the image there, you can see that we've got a traffic light junction. where there are 3 different directions. Now, an embedded system would be used here to control the sequence of those lights, but also to manage the pedestrian crossings that are there. The reason we wouldn't use a traditional computer with Von-Neumann architecture here is because it would be far more expensive to put that in place to run the system off. Also think about how we could be exposing ourselves to security threats by leaving a computer in a public space. Embedded systems can be found as a part of larger systems which have a very specific purpose. Things like car engine management systems, which are becoming increasingly diverse and offering more functions, traffic light systems, and aviation. Some traffic light systems also use motion detection at night to detect where traffic is coming from and change the lights into a sequence that will allow it through. Other examples include things like domestic appliances, microwaves, dishwashers, fridge freezers, washing machines, tumble dryers. Household security, petrol pumps, baggage systems at airports, and cars are becoming increasingly dynamic in the services which embedded systems can offer. This is not all of them. There are many different other examples, and essentially they rely on input from sensors. So if you think about a fridge, for example, if you leave the door open for too long, it will start to beep, and that is to signal that there has been a change in temperature or the door has been left open for too long to encourage you to shut it. Some form of heat sensor or a motion sensor will be detecting this. If you think about security systems, you may have a burglar alarm at home which has sensors in each room, and they will light up whenever they detect movement. That is the core input to any household security system. All of these systems use different inputs which come from different forms of sensor. Smart meters are being installed in many homes across the country. They're used to monitor the amount of electricity and gas that is being used within a household. They can then send a reading directly to the energy provider so that bills can be made more accurate for people, and they only pay for the energy that they have used. The benefits of using embedded systems include reduced cost of manufacturing the device and maintaining it, reduced size, improved performance because they only have a specific task to focus on. If you think about your desktop computer or your smartphone, there are lots of operations going on in the background. With some embedded systems, such as your microwave, they don't need to have operations going on in the background, which essentially would lead to unnecessary drain on resources. Also, the software is designed for very specific purposes in the embedded system, and they will come with very simple interfaces for people to interact with. They're also very reliable and robust, as there are very few things that can go wrong with them.